Hi, I'm Bob. Welcome to the tutorial on solving exercises from the textbook Microeconomics, Theory and Applications with Calculus, the 5th edition. Today, we will explore the Stackelberg Oligopoly model and tackle the problems related to Stackelberg equilibrium. Let's start by solving exercise 4.1. Duopoly quantity setting firms face the market demand P equals 150 minus Q1 minus Q2. Each firm has a marginal cost of $60 per unit. For part A, what is the Nash-Cournot equilibrium? We use the firm's best response functions to solve for the Nash-Cournot equilibrium quantities and price. Firm 1 faces its residual demand curve as follows, and its marginal revenue curve that corresponds to the residual demand curve can be written directly. Firm 1 acts like a monopoly with respect to its residual demand. The first-order condition for profit maximization is marginal revenue equals marginal cost. It leads to Firm 1's best response function, expressing Q1 in terms of Q2. It indicates how much Firm 1 will produce for any given Firm 2's output to maximize its profit. Since the two firms move simultaneously, we can write Firm 2's best response function by symmetry. Solving the two best response functions, we obtain the Nash-Cournot quantity and price. Each firm produces 30. The market output is 60. The market equilibrium price is $90. For part B, what is the Stackelberg equilibrium when Firm 1 moves first? Firm 1 is the Stackelberg leader, and Firm 2 is the Stackelberg follower. The leader knows that the follower will observe the leader's output level and produce according to its own best response function. The Stackelberg follower's best response function is the same as the Cournot oligopoly's best response function. We substitute Q2 with the follower's best response function, so that Q2 is no longer in the leader's residual demand function. We can write the leader's marginal revenue function, MR1R. The Stackelberg leader acts like a monopoly with respect to its residual demand. The first-order condition for profit maximization leads to the Stackelberg leader's quantity, 45. Substituting the Stackelberg leader's quantity into the Stackelberg follower's best response function gives the follower's output of 22.5. The market output is 67.5. The market equilibrium price is $82.5. A variant method is to write the Stackelberg leader's profit function and use the first-order condition for profit maximization to solve for the leader's output. Let's go to exercise 4.2. Determine the Stackelberg equilibrium with one leader firm and two follower firms if the market demand curve is linear and each firm faces a constant marginal cost M and no fixed cost. Suppose the market demand curve is P equals A minus B times the market output Q. Firm 1 is the Stackelberg leader and sets its output first. It knows that firm 2 and firm 3 are Stackelberg followers and will set their output according to their best response functions. We tackle the problem in 2 steps. In the first step, we derive Stackelberg followers' best response function. There are 3 firms in the market. Firm 2's residual demand and inverse residual demand are as follows. We can write firm 2's marginal revenue that corresponds to its residual demand. Firm 2 operates like a monopoly with respect to its residual demand. The first order condition for profit maximization leads to firm 2's best response function. It contains Q1 and Q3. By symmetry, the 2 followers' outputs should be the same. As a result, firm 2's best response function contains only the Stackelberg leader's output Q1. Firm 3's best response function is identical to firm 2's. In the second step, we plug the followers' best response functions into the leader's residual demand and find the Stackelberg leader's output. Firm 1's inverse residual demand function becomes a function with only its own output Q1. Its marginal revenue that corresponds to the residual demand also contains only its own output Q1. The Stackelberg leader operates like a monopoly with respect to its residual demand. The first order condition for profit maximization leads to firm 1's Stackelberg equilibrium quantity Q1 star. We can use the followers' best response functions to find the followers' output. The market output is the sum of them. Substituting the market output into the market demand function gives the equilibrium price. Let's solve exercise 4.3. Show the effect of a subsidy on firm 1's best response function in solved problem 14.3 if the firm faces a general demand function PQ. We will examine the subsidy's effect on the firm's best response curve in the Nash-Cornell model. Suppose the market demand is linear as P equals A minus B times Q. Firm 1's residual demand is Q1. Its inverse residual demand function is as follows. We can directly write the marginal revenue that corresponds to the residual demand. Firm 1 operates like a monopoly with respect to its residual demand. The first order condition for profit maximization leads to firm 1's best response function. For any given level of firm 2's output, the best response function gives firm 1's optimal level of output that maximizes its profit. Next, we consider the effect of a subsidy. The subsidy lowers the firm's marginal cost M. As the marginal cost falls, the intercept term becomes larger, while the slope term is unchanged. So the best response curve shifts upwards or to the right. The new best response curve is parallel to the old one. Or equivalently, we can partially differentiate Q1 with respect to M while holding Q2 constant to find the sign of partial Q1 over partial M. It's negative, meaning that as the subsidy causes the marginal cost to fall, Firm 1's output Q1 increases by holding Q2 constant. In other words, Firm 1's best response curve shifts upwards. Let's answer exercise 4.4. Two firms, each in a different country, sell homogeneous output in a third country. Government 1 subsidizes its domestic firm by S per unit. The other government does not react. In the absence of government intervention, the market has a Nash-Carnot equilibrium. Suppose demand is linear, P equals 1 minus Q1 minus Q2, and each firm's marginal and average costs of production are constant at M. Government 1 maximizes the firm's profit. So the government's optimal S results in its firm producing the Stackelberg leader quantity and the other firm producing the Stackelberg follower quantity in equilibrium. We solve the problem in two steps. In the first step, we find the Stackelberg quantities. For a demand curve, P equals A minus B times Q1 plus Q2, and two firms with a marginal cost of M. The equation 14.31 in the textbook gives the Stackelberg leader's output and the Stackelberg follower's output. In our example, A equals B equals 1. So the Stackelberg leader and followers quantities are as follows. In the second step, we will show that the Nash-Carnot equilibrium with a subsidized firm gives the same quantities as in the Stackelberg model. Equations 14.21 and 14.22 in the textbook are the Nash-Carnot equilibrium outputs for the two firms if one firm pays a tax of X. The subsidy can be seen as a negative tax. S equals minus X. So the unsubsidized firm's output and the subsidized firm's output are as follows. Substituting A and B, we have the two firms' quantities. We assume Firm 1 receives the government's subsidy. We then calculate the total output and the market price. The government's objective is to choose the amount of subsidy to maximize Firm 1's profit. The first order condition for profit maximization is that the partial derivative of the firm's profit with respect to the subsidy equals 0. We obtain the optimal level of subsidy. Substituting it into the firm's Nash-Carnot equilibrium quantities gives the result. If the government maximizes the firm's profit, then the Nash-Carnot equilibrium with one subsidized firm is identical to the Stackelberg equilibrium. The Carnot firm with the subsidy produces the Stackelberg leader's output, and the other Carnot firm without the subsidy produces the Stackelberg follower's output. Let's address exercise 4.5. We are required to use graphs to show how the entry of rivals affects the Stackelberg leader's output. discuss the difference between a market with a Stackelberg leader and one follower versus a market with 3 followers. We can use the graphs and math to show the results. The graph shows the market demand curve D, the Stackelberg leader's residual demand curve DR, and the responding marginal revenue curve MRR. As more firms enter the market, the residual demand curve DR rotates and becomes flatter. The marginal revenue curve corresponding to the residual demand also rotates and becomes flatter. The blue lines are the new residual demand and marginal revenue curves. Although the curves rotate, the intersection of the marginal revenue and marginal cost curves is unchanged. The Stackelberg leader's output is unchanged as a result. The equilibrium price falls. The total market output increases. Compared to 1 Stackelberg follower, 3 Stackelberg followers cause the market equilibrium price to fall and the market output to rise, although the Stackelberg leader's output is unchanged. Next, we'll use math to prove it. Suppose there's 1 Stackelberg leader firm and n-1 Stackelberg follower firms. In the first step, we find the follower's best response function. The follower firm 2's residual demand curve is as follows, where Q1 is the leader's output and Q2, Q3 to Qn are the follower's outputs. Firm 2's profit pi 2 is price minus marginal cost and then times Q2. Substituting P and using the first order condition for profit maximization, we obtain firm 2's best response function. By symmetry, all the followers should produce the same output level, Q bar. Then we have each follower's best response function, indicating the follower's optimal output choice in response to each leader's output level. In the second step, the Stackelberg leader knows that the followers will observe its output level and then act according to their best response functions. We substitute each follower's best response function into the leader's residual demand curve and write the corresponding marginal revenue function. The first order condition for profit maximization leads to the Stackelberg leader's quantity. It does not depend on the number of firms in the market. That means, as more firms enter the market as Stackelberg followers, the leader's output is not affected. Using the follower's best response function, we get each Stackelberg follower's quantity. The market output is the sum of them. As the number of followers increases and approaches infinity, the Stackelberg equilibrium market quantity approaches the competitive level. Finally, we have the market price from the market demand curve. As the number of followers approaches infinity, the Stackelberg equilibrium price goes to the competitive level, the marginal cost. Thank you for watching this video and subscribing to my YouTube channel. See you next time.